Did you hit the share button at the bottom? Oh, there we go. Okay.
Yeah, okay, you can see that.
Yeah.
Yeah, so my name is Hari, and I actually am staff engineer from Alibaba, and you can check my GitHub account at the restore. I'm one of the main contributor of Kubernetes main repo since 2015 with 173 commits merged in Scheduler and Kubernetes. I'm also one of the reviewer of sig-auth and sig scheduling and focus on content runtime interface, resource management, and scheduling performance tuning stuff. I'm also one of the maintainer of CI spec, especially for cut containers since 2017. I began working with working group Multi-Tenancy since 2017. You can check one of my speak of the working group Multi-Tenancy deep dive during KubeCon North America. As I speak about the Alibaba team in related to Kubernetes, we are actually highly invested in the working group Multi-Tenancy, which we figure out as a long-term strategy. That's why we actually proposed the virtual cluster-based multi-tenancy model in the working group. And in Alibaba, actually, we have two models to fix the hard multi-tenancy problems. And they basically have different multi-tenancy views, but we'll have the same resource isolation model. So the first one is intra-cluster, which is quite similar to what we are proposing, what the community is proposing during the working group SIG multi-tenancy, working group multi-tenancy. And also we are proposing another model, which name is virtual cluster, which will give the tenants per tenant per virtual cluster model, but underlying infrastructure is actually the same. We will need to fix the same like networking service model, and of course with the runtime model. So as you can see here, Alibaba actually have very solid use cases and product for both of the multi-tenancy structure. The first of all is Alibaba Serverless Kubernetes, which is one of our public cloud product. And also we also have another product which name is Alibaba Serverless Infrastructure, which use the virtual cluster multi-tenancy model and serve over web scale cluster internal. So for the community part, we think that Alibaba, the team and me can also still continue to contribute and engage with the working group multi-tenancy. We hope to move our internal experience to the community and to cooperate and push both intra-cluster and virtual cluster model to real practice and fix various issues, including the multi-tenancy view, the multi-tenant service and DNS, the multi-tenancy SIG and CI implementation, and of course, sandbox runtime, and in the future, eventually we will make Kubernetes tenant aware. So that's the basic introduction of myself. And if you have any questions, please feel free to ask.
Cool, thanks, Harry. Would anybody else like to nominate themselves? Okay. And if you did, just ping the chat. But for one moment, I'd like to give Sanjeev another chance to go because I was not recording when he went, so his introduction won't be included in the video. Sorry, Sanjeev.
Yeah, should I go again?
Yeah.
Hi, so I actually was thinking of producing a couple of slides, but in the past, we've been less formal, so I apologize I haven't produced slides. But I will actually go ahead and share the deck that we did, just so I have something to show. And if that's okay, just to reflect on some of the work that we've done. So if I can take the ball.
Yeah, I think sharing's just open if you want to grab it.
Yeah, okay. Okay, just give me a minute. I wasn't expecting to do this through slides, so let me just pull it, just 1 second. Okay. Yeah, so I hadn't produced a formal introduction of myself, but I'll just share this as a sort of fill-in. So my name is Sanjeev Rampal. I've been involved in this group particularly over the last several months, although being on and off involved with this working group for longer than that. And I've been at the core of driving the activity for the last 6 months. Essentially, this group was flailing, to be honest. Without meaning to be critical, this group was actually flailing for a while. And I feel like I've helped in a significant way bring some structure since the meeting we had in Seattle, putting together the working group direction, as well as working with folks like Isui on prototypes of tenant controllers and tenant models. And then we've also created this framework for sort of having a set of architecture models, which I'm showing here in terms of running multi-tenant Kubernetes on IaaS, leveraging the IaaS tenancy versus leveraging CRDs, versus the virtual cluster model that Hadi just mentioned, and also working towards introducing tenancy as a first-class object in the K8s API. So I've been trying to have a holistic view, trying to accommodate every perspective. I've also been very familiar with the work that has happened in different vendors like Openshift and Rancher, and personally have been trying to learn from the best points from those products, as well as bring in that to the community.
Just as a note, Sanjeev, we're not seeing your slides.
Oh, you haven't been seeing it all? Great. Let me start yet again then.
The talk track was pretty good, so I don't think it lost anything.
Okay, sorry. Yeah. So yeah, I hadn't actually produced a formal slide deck to nominate myself, and if you guys need that, I think it'll be good to do that, so I could send out a couple of slides after the call as well. So I'm just sharing the work that we presented on behalf of the group to illustrate the fact that I've been strongly involved in this working group for a while. And to jump to this other slide here, we are so as I said earlier, this working group has been flailing for a while, and I do believe that I gave a strong push to create some structure, and that has led to our getting better organized and having a better framework and having some concrete development over the last 6 months. This particular slide is just illustrating the fact that we have been welcoming different categories of proposals. And because of the work done in the last 6 months where some structure has been created again, I think more contributions are coming in. So I, in my opinion, have played a strong role in creating that structure for the team, which has resulted us in kind of getting back on track in this working group. And I'm very motivated to help this community take this topic forward. You can refer to my talks both at the Aqua conference as well as KubeCon. Prior to that, I've been involved in terms of the open source community. I've been involved in products like the Conti CNI network plugin. I have contributed to the installers for projects like Openshift, and I have done a lot of product development in the closed source area for Cisco, developing products that are deployed all over the world. I have over 20 years of experience, and I'm strongly motivated in helping this team move forward in this area. And then also worked with closely with folks like Yisui and others on some of the initial controller prototypes for tenant templates and tenant CRDs and so on, some of which we documented and demoed at the conference as well. So that's my background. I'm sorry I don't have a formal deck to introduce myself, but hopefully that gives you all a reasonable picture, and I'm happy to send out 1 or 2 slides after the call, giving you a summary of my background. I'm actually taking pointers from Harry here because I hadn't actually planned on producing a formal slide for myself. So thank you. Any questions?
Cool. Okay, thank you, Sanjeev. Did anyone else want to put themselves forward at this time? Okay. Yeah, cool. Well, thank you very much, Harry and Sanjeev, for those presentations. They were very good. We meeting, which is going to be going over Faye's proposal about multi-tenancy at Alibaba. Faye, if you want to present. I know that we ended up getting cut off at our last meeting, which at this point was a month ago. So you were up on deck if you'd like to present what you were going over.
Sure. Let me try to share my screen.
Yeah, we can see it.
Good. Okay, so yeah, last meeting I have a brief introduction to the virtual cluster architecture because I only have 10 minutes. So last meeting I go over mainly this figure about the high-level architect. So today I may take another 10 to 15 minutes to first recap this figure a little bit, then go through more about the multi-tenancy service model. Is one of the solutions that we have think about how to provide network isolation in the area that people need hard multi-tenancy to provide isolation for the tenant parts. Yeah, as a recap, so what we actually propose as a virtual cluster, it actually has a supermaster, which actually is a resource provider. It manages all the physical nodes resource, and the tenant master is deployed using a standard Kubernetes on Kubernetes KOK model, and so then the tenant owns the tenant master, which has a full API control as an API server. The key here is each node we will have a VM agent. So the VM agent itself is just there's a mapping from the VM agent to the actual nodes in the tenant master, and basically in the tenant master it will use the VM agent as a node. So what we does is every time the tenant will work on the tenant master to do the pod resource provisioning. And the tenant and all the tenant the path information we are going to be synced to the supermaster using the syncer using a sync manager in the tenant controller. So then the Kubernetes actually talk to the supermaster. It watch for the changes in the supermaster for the pod creation, deletion, addition, etc. And then do actual pod provisioning, start all the container in the pods. And the results will be synced back using syncing back to the tenant master, so that the tenant master actually knows the pod is up and what is the status of the pod. So all the information are synced by the tenant controller, sync back from the supermaster to individual tenant master. So this is the high level architecture. So as a recap, so if you see with this view, the pod creation workflow is actually done in this way. The tenant creates pods in the tenant master. The sync manager copy the pods back from tenant master to supermaster, but it also adds the tenant prefix to the pod name, all the label and key value, etc., to avoid any conflict in the supermaster. And the actual pod scheduling is done by the unified scheduler runs in the supermaster. The unified scheduler chooses a node for the pod in the supermaster. The Kubernetes creates pods in the stacking nodes, and the sync manager creates a node object in the tenant master using the stacks nodes VM agent runtime info instead of the Kubernetes info. Then it updates the pod states back to the tenant master. So overall, from the tenant perspective, the pod is actually runs in a node whose kubelet is viewed as a VM agent. So this is the in general idea of how the tenant master interact with the supermaster for the pod lifecycle management. I didn't fully describe all the other workflows for the pod lifecycle management, like deletion, like how we forward all the API calls to kubelet through the VM agent. So this part of work, I have a plan to fill the rest of content in this talk. But if people actually indeed interested, I have slides for this. All the other workflow are described in the slides in this link. People can take a look. So the next, I'm going to talk about take some time to talk about the multi-tenancy service model, because this is actually one of the biggest problem that we are trying to solve in our proposal for virtual cluster, because the service concept is widely used in almost all Kubernetes use cases. Like all the stuff sets need the service. People use the service to expose to expose all the network traffic and let people actually just the service is the key to allow the container running pods to interface with outside world or within the cluster. So we have a problem. The problem of the current the service model is it is designed based on the the network model that Kubernetes was originally designed. Basically, it's a flat network model, means every pod on the cluster is supposed to talk to any other pods in the same cluster, and all the agents on the node can communicate with all the pods. The agents including all the in the kubelet or all the CNI CSI plugins. But this model is largely simplified all the design of the networking, the infrastructure for the in the Kubernetes, but it actually doesn't work very well for the multi-tenancy, especially in the hard multi-tenancy cases. The problem is in the multi-tenancy cases, the pods should supposed to only talk to the pods within the same belongs to the same tenant. They shouldn't have any other ways, I mean, indirect ways or implicit ways to talk to other pods that belongs to other tenant. And in addition, we have, especially in some of the use cases in Alibaba, the tenant has a strong the network isolation requirements, in the sense that they have their own virtual private network configuration. The VPC can be a completely new VPC for the tenants that use the Kubernetes services, but in some other cases, it can be an existing VPC that people has already hosting the services in other components in the Ali Cloud, but they want the pods created in the Kubernetes can connect to those existing VPCs as well. So in those, so this complicated entire design for the node in the node side for the VPC configuration in the hard multi-tenancy scenario. So the biggest problem of the VPC things is if once people create a VPC for the pods, the kubelet doesn't have a direct connection to the pods network anymore without any addition configuration. And the current service model entails thing based on the service. There are a few types of service, but one of the common used one is the IP table one. The problem with IP table is the current Kubi proxy only changed the IP table in the node default network namespace. So once if you use VPC, and in some cases CNI, if CNI directly plug in the network interface to the pod network namespace, the host network IP table may not even go through for the network traffic. So the entire service model may not work. This is a kind of a hard problem because network configuration is so flexible and people can create networking their own way to produce isolation, connectivity, etc. So there is no, I don't think there is one very standard or way to solve this problem. So our way of thinking about it is we trying to propose another layer of the abstraction. We call it tenant network namespace. The idea is we trying to group all the pods belongs to the same tenant, and for the network connection, we connect them, all of them, not directly to the host bridge. Instead, we collect everything in a new network namespace. This network namespace is created for each individual tenant, as you see this figure and this figure 2. So the idea is the other pods, they have a VNS pair connect to the network namespace, and the network namespace have another VNS pair to connect to the host bridge. The good thing of this the hierarchical network namespaces is if we can have another solution to work on the service problem, because in each network namespace, all the traffic needs to go through the IP tables. So instead, we need to slightly, as long as we slightly change the Kubernetes proxy to allow them to update a particular IP table belongs to a network namespace, so this problem can work around. Basically, so the Kubernetes proxy needs to have a way to identify, okay, the tenant of the tenant owner of the service, and if they know the tenant owner, they can find the network namespace that belong to the tenant. Then they instead of directly manipulate the IP tables in the host network namespace, they can manipulate the IP table in the tenant network namespace. So in this way, the IP table based service will still work. So that is one way. Basically, in a nutshell, what we want to do is we propose to introduce another layer or another hierarchy to group all the tenant to group all the pods belong to one tenant and their namespace into one tenant network namespace. And we propose to extend to the Kubernetes proxy to have a way to specify the network namespace whose IP table is going to be updated. So this is the idea. This is just one very high-level concept. Once you go to the implementation, there are a lot of ways to make the entire network work, given this hierarchical network.
Today, sorry, I just joined, so I might have missed. But today, there is only one network namespace per. So there's one network namespace per pod, right? And
yeah.
For each pod, whether they belong to different tenants or not, on a single host, they still have different network namespaces. Is that correct or not?
Each pod has its own network namespace, but once it's the CNI need to set up the network in order to allow the inbound, outbound traffic. The way they set is they connect each pod network namespace to the host bridge, which is a typical hierarchy. So right. There is only one outbound, hub, which is a host bridge, Then so this is a default configuration, so that Kubernetes proxy actually leverages this configuration. So they only upgrade the IP table in the host network, default host network namespace, because every traffic of the pods needs to go through it. Then the IP table can inject traffic to do the redirection to the service IP. So
okay, sorry, I'm not following. So, I mean, what's the difference between what you're suggesting and what is currently there? If we already have a separate network namespace per pod, then how are we, or are you suggesting that for all pods that belong to one tenant, they should all belong to the same network namespace rather than each one having its own network namespace?
So each pod has its own network namespace, but if you look at this one, the figure, can you see my arrow?
Correct.
Yeah. If you look at this one, so yes, this is a network namespace. The VNS one belongs to the pod network namespace. That is okay. But if the pods needs to send traffic outside of the node, they have to go through to the node Ethernet this is the ETH0, right?
Mhm.
So without my proposal, what it does is this Venus pair will be directly connected to the host bridge. So this is the default hierarchy, right? So the path network namespace directly connect to the host bridge using the Venus pair. So every path goes through the single host bridge to talk with the Ethernet in the host. This is the default configuration. So
Okay.
why we have this default configuration? Because every traffic need to goes through this Venus pair goes through the bridge, and every traffic need to go through the IP table for the traffic routing. Then the Kubernetes proxy, they only change the IP table of this host bridge, of this non-usual work. Now the problem of the tenant is, if people use VPC, there's no guarantee that there is a Venus pair connecting from the path to the node, because the path network can be different from the node network, because paths need to have a private network. And if the CNI directly plug in an Ethernet device to the path network namespace, the network traffic will not go through the host at all. So then the default network IP table-based service doesn't work.
This is Kural actually. Sorry, can you hear me?
Yes.
So I'm from Intel. I work extensively on the networking. So what you're proposing here is that you have a different host namespace per tenant, right?
Yes.
So it means that you have to modify the sandbox code of the kubelet, right? That the kubelet is basically currently gets the Linux namespace, and then it will bind that sandbox. So when you run your Docker or something, it will create a sandbox container, and that container holds the sandbox. In this case, what you're doing is like you bunching all the tenant pod in a separate namespace. So it means that you will be modifying some of the Kubernetes core components, right?
So in this, for this particular purpose, my current thinking is we don't have to change the Kubernetes, because this intelligence should be done by the CNI plugin.
Okay, so in the CNI you want to change the, so okay, let me get it like this. So in this case, the sandbox creation, right, that is done by the till it's in with the Docker shim, right? That is the one creating the sandbox, right? The kubelet is basically, the CNI is basically just doing the network plumbing with that sandbox which is provided by the Docker shim. So I'm just trying to understand how you can do it only with CNI.
I think CNI can still like working as a controller to watch for the
Okay. But the Docker shim is the guy will give the host namespace information to the CNI. That's what I very sure about it actually. So maybe we can do comments on the document. I don't want to block this one, but we can. I will follow up with the document. Yeah.
Sure. I understand what you're talking about. So connect. Yeah. So the problem is, I think you're asking who is going to create those tenant network namespace. And
yeah, exactly. And that part will be still, it's in part of kubelet, right? Docker shim is handling that.
We can talk in the document. I think we have some thought on that side.
Okay. Cool.
Kubernetes shouldn't. We don't anticipate the Kubernetes will make the change for this.
Okay.
But we do have some talk. If you look at the doc, we have some discussion about what need to be changed. Yeah. Okay. Let's see if anybody else has other questions. Then I can go to that particular issue to see if we need coordination or cooperation for Kubernetes, what needs to be changed. But at least one thing is Kubernetes proxy in our proposal needs to be tenant aware.
So sorry, go ahead.
Faye, so I think you're saying, at least from a network isolation perspective, a lot of this could be done purely in enhancing the CNI. But it sounds like we haven't really studied all the different functions that would sort of, whether it is through kubedns or whether it's logging or so on, that need to be then made tenant aware. I think the basic isolation can be done purely in the CNI plugin, but probably needs a more detailed study, which you may have already done perhaps, of other sort of components that need to be made tenant aware. And I think you were just last saying that maybe kubeproxy at a minimum would need to be tenant aware.
Yes.
Like we need to have even more components to be evaluated.
Indeed. Actually, in order to make service work, so kubeproxy is just one way, but there are some other functionality. I think if you look at this comment, Zheng Yi Lai actually bring up a very good question, because he's talking about the health check. So the health check is a function that Kubernetes actually provide. It needs to have a direct connection to the pod for this purpose. But there is a few problems in this approach, because tenant VPC network, actually the IP can overlap. It's actually possible. Now then making the Kubernetes to inject in the individual paths through IP difficult, even you provide the network connection. So one way what we think about is we have to slightly change the Kubernetes to, once they do the network liveness probing, they have to enter the path namespace and do the query. So this is the one way that Kubernetes has to be tenant aware. So this is just one example. We probably have some other examples about how Kubernetes needs to be changed. I didn't list all of them, but at least we already thought about at least a few places Kubernetes needs to be changed in order to make sure all the service account, service, and the lives, and some sub functionality that Kubernetes provides that requires direct connection to the pod work. But the bottom line is those changes. I think once people buy in the idea, we can make those changes. Those changes highly possible, because we got some approval for the SIG tech lead to say they're willing to cooperate with us for those changes.
Yeah, this is Reza. That is actually a good change, because I think the problem with health check also exists with Istio. So that's a problem that needs to be addressed for multiple reasons.
Yes, I think that's a very good point.
So I had a question along those lines. With Istio, it actually alters IP tables. So in this situation, if one of the tenants deploys something like Istio, does your modified kubeproxy pick up changes to IP tables, or does it only push them out? Or how do you handle that, and how do you prevent conflicts?
Conflict in terms of the IP?
Yeah, so IP tables from the per node to the actual underlying OS, or per tenant to the underlying OS, unless or are you duplicating? I guess this diagram doesn't really, I guess, visualize to me in my head how these IP tables are working in terms of the actual underlying OS.
Yeah. So the problem is, if you look at this figure, so the idea is, in the default, if we don't do any changes, the kubeproxy will change the IP table in the nodes, which I didn't draw it. Suppose there is IP table here.
Right. All right.
So the idea is, with my proposal, the kubeproxy will change the IP table that belongs to the tenant network namespace. So different tenants have different tenant network namespace, which means Kubernetes actually manipulating different IP tables for different tenant.
Okay. But the IP tables remain.
So the host IP table actually doesn't change at all.
Right. So, but within the tenant itself, though, you have full access to those IP tables?
Yes.
Okay, cool.
Kubeproxy can work as root. It can access every network namespace. So the idea is it has to know where to go. That's the key. Because currently, if you look at the API, the kubeproxy doesn't have a way to provide the tenant information. So that's a problem. So that's actually the motivation that the modification that we actually suggest.
But wouldn't this also impact CNIs directly as well, right? Because something like Calico would need to talk to will have to be tenant aware as well, maybe.
Yes, indeed.
Yeah.
Well, the idea would be to have your own kube proxy, right? So you don't have to change the standard kube proxy. Like, for example, Open Contrail deploys its own kube proxy. So kube proxy is just a plugin. So in a way, you don't have to modify the standard kube proxy. With whatever CNI you're doing, you develop the kube proxy as part of that CNI.
I think the point here is that at a minimum, the CNI plugin will definitely need changes, need to be made tenant aware. And the question is what more components need to be made tenant aware. Perhaps kube proxy at a minimum, but others as well, and that needs to be studied. So really the original desire seems to be, and correct me if I'm wrong, Faye, is to try to keep as much changes limited to just the CNI plugin as possible, but it definitely does appear like we'll have to evaluate every other component as well. But
Yes.
the more we can limit it to the CNI plugin, the less disruptive it would be.
Yeah, the CI plugin itself cannot solve the problem for sure, especially in the service side. So, I mean, you have some other ways to work on this problem because you can choose some other types of service like don't use IP table at all. So the entire solution, what I'm talking about, is try to solve the problem with people using IP table.
And many CNI plugins do the service load balancing function directly themselves, right? They only rely on kubeproxy for host traffic, like services that are available to host networks. Like if it is pod-to-pod services network, some CNIs handle the service load balancing directly without relying on kubeproxy.
Yes, this is Yang from Alibaba. So I think we can start with the CNI plugin, and we can try our ideas with the CNI plugin, which we already did at Alibaba. I think the second step that we can do is to clearly define the networking model for tenants, so that we can try to push the upstream to make more component to be tenant aware. So actually, Faye mentioned that Kubernetes needs to be tenant aware because of the health probing stuff, and actually, there are many other stuff that need to be tenant aware. For example, if you deploy a daemon side, right? The daemon side may want to check the health of some pod, and the daemon side cannot really connect to a pod IP, and maybe the daemon side actually belongs to one tenant, and the IP address of the daemon side actually needs to be inside one VPC. But if you deploy it on the node, it will export the node IP directly. So there are many other areas that we actually want to improve for the networking of Kubernetes. So also this problem is actually decoupled from the virtual cluster approach that we mentioned. This is a separate problem of the networking isolation. So I think the way to push this forward is probably we can work together on defining a networking model for the multi-tenancy, and we try to see what other components that we need to improve to more tenant aware. We already talked with the Kubernetes team and also the networking team. So I think their suggestions also let us to define the tenant model, and then we go back to them and try to push some changes to the upstream.
Hey, this is Reza. I think I didn't make my point clear before. There are CNI plugins which replace kube proxy. They have their own kube proxy. So there's definitely cases where kube proxy is being replaced with specialized kube proxy. So I think it doesn't make sense to talk about Calico and changing the standard kube proxy to handle multi-tenancy. I think it's perfectly fine to say we have a multi-tenant version of Calico, for example, that comes with its own kube proxy. I think that's a much easier problem to solve than try to massage the standard Calico CNI and a standard kube proxy to be multi-tenant. Why not say, well, there's a multi-tenant version of this which comes with its own kube proxy, and just split off.
Yes, I believe that is what is. I think everyone is saying here that you can't take any old CNI and expect it to work. It would work better with CNI that is multi-tenant aware. But keeping as much changes limited to the CNI would be better rather than spreading the changes through other Kubernetes components?
Sure. I'm just talking about replacing the standard kube proxy with a multi-tenant kube proxy.
Yeah, I think for the kube proxy, we can have our own one because it's totally pluggable, and different CNIs can have their own like kube proxy. But for other problems, probably we still need to to change the kubelet. I think it's not that really that hard to push them to change stuff if we have a clear like a multi-tenancy networking story for them.
Okay, Tasha, I think I better stop here because we have another agenda.
Okay, thank you so much, Faye. This was really interesting. Cool. Tom, you were going to present on some tools that you had been building for some clients you've been working for.
Yes, thank you for letting me speak here. I will share my screen and provide a quick overview of what we're doing. So everyone has their own tenant controller, so this one's mine. Apparently naming is hard, and we all chose the same name. So trying not to conflict things. One of my clients is the administrative offices of the US courts, and they landed on Openshift for their Kubernetes environment. The administrative offices are setting up several clusters to be used by courts for deploying their court-specific applications, as well as some centralized national apps, as they call them. They want hard multi-tenancy for isolation and security, but also from a finance perspective. The courts have their own budgets, and they need to therefore pay for the resources that they want to consume inside of this centrally managed environment, but they don't want to have to stand up their environment themselves. So that's the kind of overview of the environment. So for our particular multi-tenant solution, we were looking at a explicit approval process. Courts can't run on Openshift without getting approval from higher ups as well as finances and getting those pipes together. Getting approval to run in some clusters does not give you permission to run everywhere, so we need kind of differences between the runtimes. Sysadmins don't want to be doing things, so we want tenants to be able to provision their own projects. We found that project namespace provides a nice isolation for your application or for your court's application for your one court. So we wanted to keep that model rather than having single projects and namespaces for each tenant. We want to integrate nicely with LDAP or SSO or SAML or however you guys want to do authn and authz. And we want to be able to use the groups inside of those for permissions on who can provision projects and who can change default role bindings and some of these other capabilities. This is like tenant-specific project templates. It's not explicitly built that way. It's kind of ad hoc as we've added things. But essentially, each tenant is allowed to create some custom objects that get inserted into each project as it's created. And the ones that we've done for now are network permissions and default role bindings, so that when projects are provisioned, the developer teams inside of each of those courts would have access by default, rather than having extra steps for tenant admins to go in and provide that. And then from a monitoring perspective, tenants should be able to have a quick overview of the resources that they're consuming and get a better understanding of that, as well as cluster admins at a cluster level can aggregate those type of fields. So the high level overview is that we have a controller that does all the work and actually manages these tenants across multiple clusters. We have an API that essentially is allowing us to control RBAC on properties inside of our tenants. So we want tenants to be able to modify the project list of what projects should be created, but we don't want them to be able to modify the cluster resource quotas that are defined for those tenants. So we have a specialized RBAC model that gets implemented in an API call so that people can still use CLIs, and the UI that tenant admins love will be there. There's a Swagger site to allow the two to hook together. And I'll show the UI and some objects in a minute. The tenant controller we built actually uses KubeBuilder, but it's very OpenShift specific. And what I mean by that is that we specifically create projects, not namespaces. We leverage cluster resource quotas for managing resources on individual clusters. So it does not directly translate to something that would work on Kubernetes vanilla by default. But I would like that flexibility going forward if this is of value to other groups. As I mentioned, the API allows for these specialized RBAC rules. So when a change is implemented or requested through the API, it looks at who's making that request and then determines, based on some business logic, whether that person is allowed to modify that property of that tenant. It also works with the get so that you can only see, your tenant or tenants that you are an admin of. And you're allowed to delegate permissions down to the cluster level so that some people can provision projects on the development clusters, but not on the production clusters. So you can have that isolation there. UI, yep, everyone loves the UI. So the high-level overview of the tenant object is that there's an overarching admin group that has ability to modify the tenant-specific capabilities here. We manage multiple clusters, so we have a list of clusters that tenant is approved for. This cluster object is referenced as a separate CRD that manages the connections there. I've been reading a lot of the documents on the GitHub site, and I really like the idea of working federation in here, and I think that would be a great long-term goal for this project, but we don't have that right now, so we've been managing that directly. Admins for who's a cluster admin, but maybe not a tenant admin. Cluster resource quotas for what quotas are available on that cluster, and then list of projects and default role bindings are the current implementations. And this has been working fine for the most part over the past several months as new tenants are onboarding and they're rolling out adoption. Let's maybe show the UI demo first. So the basic admin portal is what a user would log into, and this is the self-provisioning. I see special tabs because I'm a sysadmin here, but a tenant would be able to come on here and see what projects they have in what clusters, see their cluster resource usages across those clusters to see whether they're getting close, as well as provide links to the Openshift console for where that project is on that cluster. So it provides a centralized location where a tenant can view what they have available. They would also see it in the Openshift console, but sometimes they want to kind of have that aggregate view in one place. And if they were looking to add extra default role bindings, there's only a few that are available now, but then you can select all the LDAP groups that we're syncing up. The sysadmin has a different tab, a different capability to modify the cluster resources. So this is only specific to cluster admins, not for tenant admins, as you wouldn't want your tenant admins to be able to consume everything. So they're able to modify that, and then that propagates to a cluster resource quota on the cluster that you've selected. In terms of monitoring, we're using Prometheus and Grafana, and we've hooked that up so that we can see which tenants are using a high percentage of their resources. So we can see that there are some tenants, this JDash application tenant is using all of their cluster storage, and they've already reached out about asking for more, and we're working through the finances and the approval process there. But this gives us as cluster admins the ability to get a quick overview of who's close to asking for more resources and what resources those would be. For a particular tenant, they might, and I haven't figured out exactly how to do this in Grafana, I would like this page to only be limited to the tenant so that only someone in SDSO APB would be able to view this particular dashboard with that particular parameter, but that's not exactly available. So, but that's a whole separate conversation and project problem. They can get an overview of what they're using in different clusters. And then if they maybe have a question on, well, how much is this Jenkins project using, they can see that's using 4 of their 15 CPUs and get a little more single pane view on where those resources are being consumed. And then from our perspective, we have an overview on, this cluster has this many CPUs and how many have we allocated and how many are being utilized, so that we can get a better idea about what our utilization should be as we start selling these CPUs. We probably can sell more than we have because no one ever uses all that they have. So, how does that look over the long term, and start looking at trends, et cetera. All right. I think that's a good, there's like 3 minutes left. If anyone has questions or comments, suggestions especially, I'd love to hear those.
Yeah, Tom, this is great. This actually is very much aligned with the thoughts that we've had for the model B of the 4 options that we are tracking. Mm-hmm. 2 quick questions. Does a tenant map to an OpenShift project in each cluster? One-to-one mapping between tenant and OpenShift project?
No, a tenant can have many projects. And this is the list of projects that this particular tenant has in the development cluster, for instance.
I see. So tenant is an entity sitting above the OpenShift project and owns multiple OpenShift projects.
Correct. And that's tied together by labels, which are then used by the cluster resource quota.
I have a related question there. Hi, I'm Yoshi from Google. We were debating about the sort of the need of the hierarchical namespaces. Did you actually choose this model of tenant above the namespace because there was a demand of people wanting to create namespace as they want once they get the tenant? Is that the right perception?
That was the original mission. We had several people who like to have lots of projects because they feel like it's their own little sandbox, and especially in OpenShift where you do have that network isolation for a project.
I see.
You kind of give your developers their own little sandbox in the project without having this big project that people then worry about naming conflicts as they're testing the same app in different stages of development.
I agree that namespace of the namespaces. So when you actually have people use the default namespace, then when they try to kind of coalesce or combine together when things happen, this become a problem. So I think I understand that. Thank you.
Yeah.
Hi, this is Kural from Intel. Actually, we are working on the Sanjeev and Yushin from Google's tenant controller. So we are looking to have a tenant manager on ONAP and to have some kind of a tenant resource quota. So we took the proposal and we were working on that. I just put the link here actually. So when I was seeing your demo, it was same what we are proposing actually in the ONAP actually is basically to have a tenant quota, which is one layer above the Kubernetes from ONAP will using that tenant and sending that one. Yeah.
And one of these roadmap items I think ties better with tenant quota because right now we have cluster quotas that the sysadmin then needs to manage individually. It'd be great if we had a tenant quota, say for all development environments, both East and West, and then there's that single place that kind of lets you move your resources between the environments without having to update the CRQs of each individual cluster. And I think that would be a really neat feature add-on for that.
Okay.
Yeah.
Cool. Well, thank you so much, Tom. I think there's definitely a lot of interest in seeing how we can pull this into the work we're doing with the Tenant CRD. So yeah, let's keep it going.
Thank you. Let me know if someone wants to reach out on Slack. I'm Runyon TR. Feel free to reach out.
Did you say this project is open source or closed?
No, not yet. I think the client has said that they'd be willing to look at open sourcing it. It is not currently open source though.
Yeah, but we can actually working with upstream. Maybe we can shape this model to a virtual cluster model. I mean, for one tenant, one cluster, maybe in the future.
Yeah, and I think a tenant would like that ability to think that they have the whole cluster to themselves. And I think there's no reason that these two can't coincide.
Yeah, also, I want to mention that So I see Roger's talk on the modern tenancy working group deep dive, but I think actually Model B and Model C under the hood they are actually the same thing. The Model C actually just add a view layer on top of Model B. So actually, if you can share me with your slides, I can make that clear because I think Model B and Model C essentially they are the same thing. Model C just add another layer on top of Model B because under the hood they are the same thing. So I just want to add my own opinion on that.
Yeah, thanks. I linked my slides on the agenda notes.
Cool.
Thank you.
Cool. Well, thanks everybody. Great meeting. And if anyone has anything they'd like to present next week or in 2 weeks, definitely send me a note and chat soon.
Thank you, guys.
Bye.
Thank you.